Dr. Robertson Ward, also known as the Redox Doc, he's an acclaimed community medical physician and researcher. He was awarded a medical degree from the University of Illinois, and at the University of Cincinnati, he was recognized as the Family Practice Resident of the Year. He has served in top-level positions as a family practitioner and in hospitals all over midwestern United States. Dr. Ward has directed over 15 full clinical research studies on a broad range of topics, and he has an intense interest in helping people find real solutions to their health problems. As an acknowledged expert in the field, Dr. Ward finds positive and tangible human physical transformations as he applies the science of redox biochemistry to clinical challenges in his functional medicine clinic. And this is a book that Dr. Rob Ward has authored. It's called Healthy Cells, Healthy Life, Balancing Redox for Better Health. So thank you so much, Dr. Ward. We'll hand the time over to you.
Well, thanks very much. So I'm excited about spending a little time sharing some science with you, and it's a fun thing to do for me. And so let's just dive in. Redox science has to do with the biochemistry of little tiny molecules that are produced in every cell in our body. And they're produced, as I'll talk about later, in our cells in a certain manner, and they're critical to every physiological reaction that we have in our body. And that is true for other animals and plants. So it's a broad-ranging science, and it's a fairly new field. However, truly it is riddled with well over 160,000 studies on redox science in all kinds of journals and articles that you'll find. It's really not a esoteric sort of world of science. In fact, there's textbooks and all kinds of wonderful things that you can wrap your mind around to if you're so inclined. Even Dr. Watson, who was the Nobel Prize winner for unraveling the shape of our DNA, has embarked on amazing theories that he's developing about where redox biochemistry plays into a myriad of health challenges from diabetes to cancer. And so we're all fighting challenges pertaining to oxidative stress in our physiology, and we deal with these things as best we can at a cellular level, but maintaining homeostasis depends on a balance of these molecules, and not always can our cells do that. So chronic inflammation or oxidative stress can ensue, and many health conditions from Alzheimer's disease to Parkinson's disease to celiac disease have their roots in breakdown in redox chemistry at a cellular level. And so, as this article points out, many major human disorders depend on redox regulations, and it is quite likely that a group of substances and the next generation of therapeutics will be coming revolving around this science because it's at the core of our biology. So I'd like to suggest that, as this little Huffington Post made a point, there are 5 emerging technologies in science that will probably shape our lives in years to come. And these 5 include redox signaling technology. So it's not, even though it may not be part of your vocabulary, or maybe it's a part of your distant vocabulary from college biochemistry, this science has been emerging right underneath our nose. So tonight I'd like to talk a little bit about our cells and the way they react, and I'm going to use this an acronym to help us develop this concept. So in order for our cells to have proper biology and to survive and thrive and do their work, they have to adapt and change at all times. So I'd like to talk about our cellular anatomy, mechanisms of adaptation, some redox science basics, and some practical solutions as well. So let's run through cell anatomy. Those health professionals tonight that are watching this will know much of this, but it's a rather interesting analogy. So we've got a cell membrane that maintains our fluid balances and things of that sort. The nucleus of a cell directs the cell action, and it helps to protect the DNA critical to cell life. The endoplasmic reticulum kind of wraps around the nucleus, and it's involved in detoxification and other metabolic functions. The mitochondria in our cell anatomy are the powerhouse. They run cellular respiration, as it's called, and it is where energy is manufactured from food. Our vacuoles prepare waste for excretion into the outside world or inside of the cell, as the case may be. Lysosomes break down nutrients to smaller components so that the cell can use them. The Golgi apparatus distributes cellular byproducts throughout the cell. So it is true, if you've ever wondered where the expression comes from, if your cells are healthy, so are you. Well, this is where it's at. Our cell anatomy is actually very analogous to our human anatomy. And so this is where that old phrase comes from. So the cell membrane is equivalent to the work of our kidney. The nucleus is like our brain. The endoplasmic reticulum is functioning very much like our liver. The mitochondria work like our lung. The vacuole is like our colon. The lysosomes our stomach. And the Golgi apparatus represents blood vessels that distribute vital nutrients and oxygen throughout the body. So given that, let's talk about how our cells work and how they adapt to the world. And we'll kind of walk our way through this, an acronym called REACT. So R represents rest or recovery, and the nucleus and the mitochondria are involved in this. So our cells require rest to allow for repair. It is during our sleep that hormones and other biorhythms orchestrate a course of events that allow for everything from repolarization of our brain cells to smoothing out our surfaces of our joints in our in cartilage of our joints. The central nervous system is a wonderful example of this. So our brain cells, astrocytes, are very sophisticated, but they're terribly slow at repair work if anybody's had nerve damage. So the other problem is that our brain cells are very sensitive to toxic exposures. So to compensate, the brain has extra antioxidants and a lot of blood flow. The brain consumes 20% of our oxygen, but only represents about 2% of our body weight. So during sleep, our brain cells repolarize. They literally restore the electrical balance that they need. And the membrane of the cells are critical in this process. Another example of recovery and how that all kind of plays out is our muscle cells. They are loaded with mitochondria for a purpose. Those mitochondria help repair and accelerate the energy production and an assistance with detoxification of a muscle cell as well. Joint cartilage, I mentioned earlier, oxidation and inflammation are directly linked to redox balance. If we lose the balance, we lose the ability to do this delicate balance of repair. So joint repair from wear and tear requires redox molecules to be present in balance. So let's talk about those little mitochondria for a second, the powerhouse. Mitochondria are critical in activating the process of repairs, and they produce redox molecules during the natural process of the Krebs cycle, or the manufacturing of ATP energy. So food is considered converted into ATP, and redox molecules are a critical part of this cycle, and they are produced right there in normal cases. So redox molecules are primarily comprised of about 4 atoms: hydrogen, oxygen, nitrogen, and chloride. So redox molecules are combinations of these atoms in 2 or 4 molecule sizes. So it could be 2 atoms or 4 atoms or 3 atoms, for example. So redox molecules are critical. They're molecular activators of every chemical reaction in our cells. They're right at the core of activating these chemical reactions from A to Z. They're also, secondarily, a primary mode of cellular communication inside and between cells. So they activate chemical reactions and they provide avenues of communication. So there are 2 categories of actions of redox molecules. They activate the efficiency of antioxidant molecules like glutathione. So they're stopping oxidative stress and block what we like to call cellular rust. The other main category of action is that they facilitate cellular communication. So they balance our tendency to have inflammatory problems, and that is a big deal. Without them, we will die within minutes. If we didn't have any redox molecules, we would hardly survive for a very few minutes. So here's the big problem. As we live and age, the mitochondria in our bodies decline in number and capacity. We lose roughly 10% of our mitochondrial density per decade of our life. And we also lose about 10% of the efficiency of the work of these little mitochondria powerhouses. So what are we going to do about it? It's a problem. And it's interesting that most all of our health problems align according to these two categories of actions of redox molecules, not by coincidence. So if we look at human health or lack of health, on one side we have problems that are directly linked to oxidative stress or cellular rust, where there's a buildup of toxins and the cell can't correct this. And as a result, the body has to try and adapt in some way, and we see an expression of disease, from heart disease to osteoarthritis, type 2 diabetes, metabolic syndrome, etc. On the other side of the equation is problems related to inflammatory issues or inflammation. And in this case, we see problems such as allergy, asthma, thyroid problems, autoimmune issues, cancer, and such. So we've got two sides of the equation, and of course there are situations where we have a bit of a mixture, but typically people tend to have a tendency to have more rust on one side or more inflammation on the other as they live their lives. So RE, E stands for eat or nutrition, and our vacuoles and endoplasmic reticulum and cell membrane are big time involved in our ability to assimilate nutrients. So we've got to take in nutrients as well as ample amounts of water to maintain our health. The kidney is designed to conserve or release water according to our needs. And our stomach not only absorbs water, but also secretes digestive enzymes and acids to help in the assimilation of nutrients. And the lysosomes, like our cell stomach, are critical in breaking down nutrients into smaller little particles for us to absorb. So the food we eat each day not only provides basic calories, but the nutrients in our foods themselves are like information for our cells and the bacteria that live within our gut. So we've begun to know that inside our small intestine is an entire ecosystem of bacteria called the microbiome or microbiota. And so bacterial populations are normally diverse, like a rainforest. There's all kinds of species. But when we eat a diet that is more of a stress diet or a survival diet, where we're eating starch and wheat and sugar to maintain life, we create a shift into a more narrow and less abundant culture of bacteria. And those particular bacteria then will code for the expression of certain genes that lead to weight gain, inflammation, and certain amounts of stress. So that inflammation will, for example, limit the absorption of some key nutrients like vitamin D. It's no wonder that we have an epidemic of vitamin D in industrialized countries today, America in particular. So these survival bacteria create chemicals called cytokines, and that causes inflammation in the gut wall. And that leads to a breakdown in some of the cells, and that causes a secretion or transmission of these cytokine chemicals right to the lymph nodes, right next to our gut wall. About 80% of our immune system lives right there next to the small intestine and colon. And it's not by coincidence. It's to help us, our bodies, understand what's going on in the outside world. So when we have about 80% of our foods coming from near the ground, vegetables and fruits, and 20% from everything else, we tend to have a better balance of nutrients. Now, what's fascinating is redox molecules are very instrumental in helping certain bacterial cultures that are very good for us to grow. And probiotics are also helpful there as well. So hydration is quite critical for our health, and we want to have trace minerals and some salts in our water to help with the assimilation of water. 2 or 3 liters of water a day for an adult is appropriate, or half our body weight in ounces. And adequate hydration eliminates conditions like hypertension and asthma. I've witnessed just good hydration liberating people from these problems. So A is for action, R-E-A, and action requires our membranes of our cells, our mitochondria, and the Golgi apparatus. In our lives, movement is the best sign that there is life. And when we have movement, well, we're kind of built this way. We're built to forage and move about, just like our cells get more information when they move about. And they're aware of threats when they're able to do surveillance around the tissues. And it's through movements that cells create opportunities to know more about what they need because of the communication process that can exist between cells through the presence of redox molecules. The nucleus in the cell gets new information from this movement, and that helps it adapt genetically. Oxygen is better assimilated in cells that are moving about, and likewise waste is eliminated through homeostasis. So redox molecules are critical in this step. The doorway in our cells to allow nutrients in and waste products out are literally hinged or lubricated in redox molecules. And redox molecules allow the nucleus to guide and direct the genetic expressions of many physiological reactions. So it's through feedback that these molecules provide, through communication from one cell to the other or within cells, that is absolutely fascinating. So the question is, how do we optimize our redox potential in our cells? Exercise is a big deal. It actually does improve that. So engaging in aerobic activities where you're literally sucking wind and having a hard time breathing is so good for us. And supplementing our body with balanced redox molecules will assist in our redox potential from an aerobic standpoint. Cleansing is critical for our cells. We've got to have cells be able to clean up the byproducts of metabolism and deal with the threat of toxins. So it's a big deal, and waste products that get stuck in a cell will cause that cell to stop doing its work, and it just simply sits there and doesn't do its work. So the vacuoles in the cell are critical in helping us get rid of toxins from a cell. So redox molecules play a key role in neutralizing toxins. The way they do this is by activating the effectiveness of antioxidants. So if you think about an antioxidant, let's say that's me, and I might have in one hand, this is a toxin. And if I'm grabbing a hold of a toxin, I need to find an antioxidant nearby. And if I can bring the two together, I will neutralize it. So antioxidants need reactive molecules to neutralize toxins. And in this case, a toxin is normally a positive charge, and reactive molecules have 2 charges. We're supposed to have a balance, but if there's not enough of these little reactive molecules to grab a hold of and bring together to neutralize a toxin, an antioxidant is not going to be able to do its work. It's there, it's in abundance, but it doesn't have its toolbox of little tiny reactive molecules that it might need. Communication, or talking, is a big deal for us human beings. And so that's the T, our last little component. And the nucleus and the cell membrane are critical in this. So cells talk to one another. There's an amazing amount of chatter and communication going on. And in a tissue, cells will actually send messages back to each other with these little molecules, these redox signaling molecules. And the signal will say, well, you're looking pretty bad. You need to get busy with repairing yourself. Or it might say, you're in big trouble. You need to just replicate yourself and replace yourself. Or the message might be from a nearby cell, you're so bad, you're causing trouble for our tissue. Get out of the way. We're going to find another cell to replicate and fill in your spot. So these constant decisions and communication about those decisions is critical to the health of a tissue. If this communication is not happening, your body will probably suffer serious consequences, because if a cell is out of balance and very sick and aberrant, it might start to replicate itself, and before you know it, you've got a tumor. So redox molecules are literally the messengers that are critical to communication. If I was to step on a thorn, the first thing to happen is a signal from my immune system. It's called an oxidative burst, and it will send out a signal saying there's a thorn, send out the troops, and that oxidative burst is actually a release of reactive molecules that we don't have them, we don't get the message out, we don't deal with the problem that might be happening. I want to spend a minute talking about the transcription of genes. It's a big topic today in our life. We talk a lot about nutrigenomics and the human genome, and it's everywhere. So we happen to code for about 20,000 genes that do specific coding for the production of proteins. There's a lot of other genes out there, but there's 20,000 that code for proteins, and they're very important. So what is this transcription really like? Well, think of a DNA segment. And if the DNA has to copy itself, it has to go to the copy room. And in the copy room, it's going to take a photocopy, and that photocopy is called mRNA. So that's step one. Now, the copy machine in the copy room is going to run fast or slow according to the presence of certain transcription factors. If we have a upregulation of transcription factor, it's going to happen fast. If there's not much transcription factor, the copy machine runs slowly. And that is the influence of redox biology. So we can upregulate transcription factor and code for certain DNA that we really want to be active, like a DNA that will help us adapt, or we may want to not have a DNA expressed. So 95% of our genetic material is subject to expression. Only 5% of our DNA is fixed. So most every important gene that we have, even genes that code for heart disease, are subject to switching according to the presence of transcription factor, and that is driven by redox chemistry. So then after we've got this copy room that's finished making a whole bunch of copies, we have a collection of papers. This big collection then it's all stacked up, and it represents what's called a transcriptome. And so that's the sum total of everything that's been copied. So we might have a transcript for bones, a transcript for brain cells, or something for muscle cells, and all collectively, these would be called a transcriptome. So there's a whole bunch of different transcripts that equals a transcriptome. So to sort of summarize, the mRNA leaves the copy center, goes to the ribosome house in a cell, remember the ribosomes, and the mRNA is coded into certain amino acid chains in the ribosome house. And that's where they form these giant protein molecules. And these proteins then will express our genetic potential. So when we code for certain proteins, we'll have better digestive health. We code for other proteins, we won't. And every aspect of our health is influenced by all this copying. And what drives the speed of the copy machine is our very redox molecules. It will either upregulate or not upregulate transcription factor. Well, getting back to our job in communication, we have, as people, we have a job as being social creatures. We interact with others, and without that interaction, we just don't have much joy. So our thoughts, just like in our cells, can create beliefs, and if we think them over and over, those beliefs can create deep feelings, and these are usually led to a feeling or an impulse to take action. So if you can change your thoughts, you can change your actions. But all of this is critical in our lives, just like it is in a cellular life. And just as cells listen to one another to understand exactly how we're doing, we get feedback from our nearby cells. Our lives are influenced probably most greatly when we simply listen. And so when we have interaction with people, we live longer. Proper social interactions can extend life by way more than 10%. So REACT represents an acronym of how our cells adapt and adjust. And at the core of what's going on with these cells is these very delicate but easily influenced redox reactions. And these redox molecules even influence the expression of our DNA and help us adapt. As was mentioned earlier by the Cotters, I have a website that kind of helps people learn about redox chemistry. It's one of my passions. And feel free to visit theredoxdoc.com. There's a bunch of newsletters that I try to get out as often as possible, and there's a subscription video course series as well. I'll also mention the book that they talked about. This is a nice little summary, and it goes through a number of health issues, as well as just describing the basics of redox biology. So I hope that's been helpful. And I'm very much open to questions tonight that might be on people's minds. I know that there were some questions that were sent in, and so maybe we can go to that.